this award has provided an overview of a range of benefits that might be generated by water-sensitive planning proposals and some economic tools for their assessment. He's provided 3 case studies, but mentioned there are numerous other examples that can be reviewed. There are 2 practical perspectives from public authority practitioners in Melbourne that are instructive. The first from Tony Kelly, the former Managing Director of Yarra Valley Water.
Hi everybody, my name's Tony Kelly and I'm going to give you a utilities perspective on water sensitive cities based on my experience at Yarra Valley Water here in Melbourne. I guess when we were thinking about how we were going to make a contribution as a water utility, the first thing we were looking at is what exactly is the problem we're trying to solve. And I think it is a mistake to come from, look, we need to put a lot more rainwater tanks in, or we need to recycle black water. In other words, come to the whole situation with a solution. I think it's much better to chunk it up to a higher level and look at exactly what are the problems that you're trying to solve. And at Yarra Valley Water, I guess the things that we were interested in at that higher level was certainly preserving the ecological value of rivers and streams, improving the reliability of water supplies, particularly in the context of the drought that we've just been through, reducing nutrient discharges to rivers and streams because, running sewage treatment plants, we were involved in a lot of that. Reduce the flooding risk as well, which is becoming worse as Melbourne grows. And of course, reducing greenhouse gas emissions, which we felt absolutely obliged to do because the increase in greenhouse gas and the climate change that's coming through as a consequence of that is causing many of these problems that I've just described. And of course, we wanted to contribute to Melbourne as a livable city, being very proud of the fact that Melbourne is one of the world's most livable cities. So how do we go about solving the problem? Well, the prerequisites that we saw were, first of all, no preconceived positions, no policy bans, and try and make the boundary conditions as wide as possible. The more you constrain the problem, the more you deny yourselves the possible integration of building a broader perspective. So we started very broad before we came in very narrow. And once we sort of complied with those prerequisites, I guess, the next key thing was, well, how are we going to assess different options? And in all of our work, our own research and development, we decided on life cycle assessment as the best tool to enable us to work out the differences between Project A and Project B and the impacts that each of those might have had on the environment. And for the first time ever, once we started using life cycle assessment, we had quantitative analysis that gave us some indication of what was better than the status quo. Life cycle assessment is a very useful tool. It's a tool which has gained a great deal of credibility and momentum around the world in assessing environmental impacts. It basically looks at the full life cycle, as the title suggests, from the design, the implementation, the construction, the operations, and even the decommissioning. And it takes that full life cycle and it assesses in a quantitative way the environmental impacts of each of those stages and aggregates that. So you end up determining what is the full life cycle impact on the environment of any particular project that you might be considering. So we bought some software, some European software, and we started to populate that with Australian data of materials and operating costs and impacts, etc. The life cycle assessment showed us that there were 3 dominant environmental impacts. The first one is taking water from rivers for use in the urban environment. Now, of course, when you take water from rivers, it can have a major impact on the ecology of the river. So that was the major impact there. The second one is nutrients discharged to rivers. So Yarra Valley Water has a number of sewage treatment plants where it treats sewage to a very high standard, I must say. But in the end, the final product, which is cleaned up water, is discharged back into rivers and streams. And that water can contain nutrients which can have an adverse effect on the ecology again. And if it's excessive, it can create things like blue-green algae outbreaks, for instance. And the final one, of course, is greenhouse gas emissions. The water industry has greenhouse gas emissions from its pumping operations, from its use of energy in that regard, for its treatment processes, both for treating water and for treating wastewater. So they were the three environmental impacts which dominated all of our assessments. So then we used these three factors to help us determine the environmental impacts of one project compared to another. So for instance, if we had a project which was proposing that we use rainwater tanks, we could assess the environmental impacts in those three categories of that proposal compared to another one which may be using recycled black water. And for the first time in our experience, it was the life cycle assessment that would give us a quantitative view of the differences between those two. And on top of that, of course, we would also use the status quo, the existing centralised systems. What were the environmental impacts of that? How much water were we taking from the rivers, how much nutrients were we discharging, how much greenhouse gas were we producing, and that became the base case against which we would compare options like rainwater tanks and black water recycling. The next challenge, of course, is once you've identified the externalities, is how do you value them? Because at the end of the day, it is important that you do assign some value. Now, what we found, luckily, was that it wasn't too difficult to assign value to the three externalities I've been talking about. Greenhouse gas, for instance, there are carbon markets around the world, and at the time that we first embraced this, there was a carbon tax proposed in Australia. So we had some numbers to play with, and that was very useful. We're also very fortunate in Victoria. We have water markets where farmers trade, buy and sell water on an open market. And that was very useful for us as well as a surrogate for the value of water taken from the environment. And it was a surrogate because the way the price is struck in this water market is the water is allocated to the environment first, and then whatever remains is available for the farmers to trade. So the price of that traded water already takes into account the environmental value of preserving the ecology of the rivers. So we thought that the water price was a useful surrogate. And then finally, Melbourne Water here in Melbourne, the utility that is responsible for drainage and waterways, they had provided incentives for new developers to minimise the amount of nutrients they were discharging from their new developments. And I think it was about $2,000 a kilogram, something of that order. And we used that number again to give us a value around the nutrient discharges. So, that was very useful, and in a few moments I'll show you a case study of how that worked. More difficult, though, were certainly some of the aesthetic externalities and some of the intangibles, and certainly these presented much more of a challenge. And we didn't spend as much time on these because of that challenge. However, no, there are methods you can use to determine some of these values. We did entertain willingness to pay. So we went to our customers and asked them would they be willing to pay for an increased level of service or an improvement in a river, whatever. And from that we were able to gauge the value the customers placed on some of these aesthetic externalities. We played with multi-criteria analysis. Personally, I wasn't too happy with that. It's very easy to build your own biases into multi-criteria analysis. So that ended up gravitating to using expert panels, which helped us with effectively the multi-criteria analysis. So ensured that the multi-criteria analysis had some objectivity and independence built into it. And the expert panel, typically we'd have academic scientists, we would have local government, we would have other utilities, people, and also friends of groups, people who had a vested interest in the local environment. So this group of experts came together, and they had the advantage, of course, is that they had more time, and they came with a level of knowledge which meant that they could distill the information we provided relatively quickly and come to some conclusions.